Good morning, good afternoon, good evening, wherever I may be watching this from. This is Collinear with another video on vectors. Now we are continuing on collinear points. So we have two questions. We have this one here, then we have this one here. The first question will be answered in this video. If OP is equal to 2 of vector A minus 5B, OQ is equal to 5 of vector A minus vector B, and OR is equal to 11 of vector A plus 7 of vector B. Show that PQ and R are collinear and state the ratio PQ to QR. So I've written the vectors here. So this question above, it ends here, and this one here will be answered in the next video. Okay. So first of all, we need to show that these points are collinear. You look at these equations like this, and then for us to know that they are collinear, there is something we need to note. There is something we call a common vector. They are going to have a common vector. So let us do this. We have our OP like that. Let's find PQ. PQ will be equal to PO plus OQ, which is equal to PO minus 2 of vector A plus 5 of vector B. OQ is plus 5 of vector A minus vector B. We group like them together, 5 of vector A minus 2 of vector A plus 5 of vector B minus vector B, which is equal to 3 of vector A plus 4 of vector B. That's our PQ. So let's write it down here. PQ is equal to 3 of vector A plus 4 of vector B. Then let's try PR. The next one we are going to try is PR. PR. So the essence of what you need to know in this, let me just leave a space. PR. What you need to know in this question is that these position vectors here, they help us to show that actually these points are collinear. Now, when we find the resultant vector like this, that is when we know that these are collinear. Alright, so PR is equal to PO plus OR. PO is minus 2 of vector A plus 5 of vector B. OR is plus 11 of vector A plus 7 of vector B, which will be equal to 11 of vector A minus 2 of vector A plus 5 of vector B plus 7 of vector B, like that. And then if we simplify, this will be 9 of vector A plus 12 of vector B. Then here there is a number which can go into 9 and 12, and that is 3. That's 3 of vector A plus 4 of vector B. So PR is equal to that. We have our PQ, we have our PR. So let's write our PR here. PR is equal to 3 of 3 vector A plus 4 of vector B, like that. So we have found PQ, PR, then the last one that we can come up with is QR. QR is equal to QO plus OR. So the essence of what I'm doing is that we're trying to think of these vectors. QR, PR. So I'm thinking of possible combinations of these letters. The letters P, Q, and R. You can do PQ, you can do PR, and then you can do QR. Those are the three possible combinations. And then we simplify. QO is equal to minus 5 of vector A plus vector B. OR is this one here, which is 11 of vector A plus 7 of vector B, being equal to 11 of vector A minus 5 of vector B plus 7B. We simplify, this will give us 6 of vector, this is supposed to be vector A here. 6 of vector A plus 8 of vector B. Then simplifying this, the only number which can go into these two is number 2 itself. 2 of 3 of vector A plus 4, like that, if you factor out. That is your QR. So what you need to note about collinear points is that they have a common vector. The common vector is this that is in the brackets, 3A plus 4B. Here 3A plus 4B. Then here it's just 3A plus 4B, like that. Alright, therefore to finish the question, they are saying state the ratio PQ to QR. That would be at the end. So first of all, let's finish the question. To conclude, this is our QR here, right there. Therefore, the points P, Q, and R are collinear. Alright, let me just erase that. The space looks like it's not enough. Therefore, the points P, Q, and R are collinear because of the common vector 3A plus 4B. So when you do all that working that I was showing, then you conclude like this. You will get the full marks that are needed for this particular question. And then we can go to the end of the question, which is the ratio of PQ to QR. Alright, so our PQ, from what I remember, was 3A plus 4B, like that. Let me first write the ratio. So PQ to QR, which is 3A, 3 of vector A plus 4 of vector B, to QR, which was 2. Then we have 3 of vector A plus 4 of vector B, like that. So to find the ratio, we just divide by the common vector 3 of vector A plus 4 of vector B. 3 of vector A plus 4 of vector B. We divide both sides. This is 1, this is 1, this is 1, that is 1. You conclude, therefore, the ratio of, the ratio of PQ to QR is 1 to 2, like that. So that's the end of that question. Thank you so much for watching. This has been Cornelius with another video, and bye bye.